is Leo Mora, and I'm your host for Suntawk. Today we're going to talk about the basics of the quantum universe. It's going to be a little bit long. I will try to make it as quick as I can. The rules are always open-minded, share information, experience to learn, intellectual development, so we can find wisdom through knowledge. And so the topics come from books, videos, articles, and information and experience from us. So these are the topics: frequency, vibration, waves, sound, levitation, numbers by Tesla. So we're going to begin with vibration, then we continue with waves, frequency, sound. We all know what sound is, so I'm most interested in levitation using sound. And at the end, we will talk about a little bit about numbers, the way Tesla saw them. So it's very interesting. All right, so I'm going to try to read as fast as I can because it's a lot of information. So basically here we have a very quick summary of all the components. So vibration at its core is the back and forth motion of an object around a central point. This can be as simple as a plucked guitar string or as complex as oscillations of an atom within a molecule. Vibration is the source of all waves. Waves are the disturbances that travel through a medium, transferring energy without the physical movement of the medium itself. Imagine a pebble dropped in a pond, ripples spread outward, but the water itself doesn't move across the pond. We have two types of waves: mechanical waves, which requires a medium, like sound waves in the air or water waves when you drop the pebble. And we have electromagnetic waves that can travel through the vacuum, like light and radio waves. Frequency. What is frequency? This is something, it's really how often a wave repeats itself given a time. It is measured in hertz, where 1 hertz equals 1 cycle per second. I'm going to show you later a graphic about this. Higher frequency waves have more cycles per second. So what is the importance of all of these, right? So basically we live supported by them in all the technologies that we use currently. So in communication, sound is crucial for us, allowing us to share information, express emotions, and doing this video. Technology, we have music, so sounds are the basic of foundation for music, providing enjoyment. Communication technologies, radio, television, mobile phones, all rely on transmission of electromagnetic waves. Medical, many of the medical machines, they use some kind of vibration, sound, waves, and frequency. So the MRIs, scanners allow you to see inside the body or inside your head. Those are the big machines that you slide in and they take a snapshot of you. Remote sensing, so radar and sonar, used in every airport and for the military as well. They use waves to detect and locate objects at a distance. It's very important to also for understanding the universe. So in astronomy, they study the frequencies of light emitted by stars and galaxies, helps you understand their composition and behavior. And in seismology, they analyze the waves so they can understand earthquakes and the structures of Earth's interior. So, vibration, frequency, and waves are interconnected phenomena that play a vital role in communication technology and our overall experience of the universe. So sound is a type of mechanical wave that produces a vibrating objects. These vibrations create pressure variations in the air, which are then transmitted to our ears. So the key components of the sound is the pitch, the loudness, and the timbre. The pitch is based on the frequency of the sound wave. Higher frequency sounds are perceived as higher pitched. Loudness related to the amplitude of the sound wave. Larger amplitudes results in louder sounds. And timbre is the quality of the sound, which it distinguishes different instruments or voices even when playing the same note. Okay. So we're gonna dig a little bit deeper, right? So we're going to explain these graphs, which is basically this is the vibration like a pendulum, right? And here is the amplitude. So the angle, the higher the angle, the louder the vibration, or the more energy the vibration has. So and the waves, the definition and the types that we already saw. The frequency is the beginning and the end. So one cycle is where it begins and where it ends. So that's 1 hertz. So what else should I share here? So we have the x-axis and the y-axis, the wavelength, the distance between the two corresponding points in the wave, 2 consecutive crests and throws. So crests are the top and throws are the bottom. Amplitude is how big this angle is, and the frequency. So the key points are higher frequency means more waves pass a given point per second. Shorter wavelength corresponds to higher frequency. Amplitude is related to the energy of the wave. All right, so this is what, for example, the sun is sending us. So this is emitting a magnetic field, and so this is the radiation that we get from the sun. So from left to right, so I'm going to read it left to right, but right to left is increasing frequency and left to right is increasing wavelength, right? So the most damaging waves that we have are the gamma rays. So these are the gamma rays. Then we have the X-rays. You know, X-rays is for looking inside the body and see if you have a broken bone and things like that. Ultraviolet radiation, it's next. And so all these radiations are bad for humans. These are not good. So, and here is the visible spectrum of the electromagnetic fields. So we have from 380 to 750 violet, blue, green, yellow, orange, and red. So this is what we see. Next to this is the infrared. So infrared is below the red. And then we have microwaves, we have radio waves, and we have long radio waves. This radiation to the right of the visible spectrum are not bad for humans. So we're not affected by them. All right, so here we have some animations. This is the sun.
Dad? We're going to the gym.
This is how you see the sound waves, or like a pebble in the water. This is how the sound is processed. So this is how you look at it in the software. And this is light going through fiber. This is how the light can travel on it. So, for me, one of the biggest examples of vibrations, waves, frequency is one of the most powerful telescopes there is the James Webb telescope, and it's just magnificent the way they built this telescope. That the cost was phenomenal. So it has a bunch of detectors, so a bunch of measuring and detectors that look at the light and the whole range, not only visible light but infrared. And so let's go with the first one, which is the mercury cadmium telluride detector. Sends near infrared wavelengths 0.6 to 5 micrometers. Arsenic doped silicon detectors capture mid infrared wavelengths 5 to 28 micrometers. Near infrared camera with 4 megapixels. Near infrared spectrograph. Mid infrared instrument that measures mid to long infrared wavelengths. Gyroscopes. The hemispherical resonator gyros, also called wine glass gyroscope. These gyroscopes measure angular motion by sensing the flexing vibration of a bowl-shaped crystal. Fine guidance sensor. This is a Canadian-made sensor that helps point the telescope precisely. So it is so sensitive that it can detect the thickness of a human hair from 1 kilometer away, or 0.6 miles away. Vibration is important because it can help identify problems with the machinery, which can improve safety and efficiency. Vibrations analysis is a key tool for predictive maintenance and conditioning monitoring. So the important is detects faults. Vibration analysis can help identify potential faults and malfunctions in machinery, reduces downtime. Vibration analysis can help reduce unplanned downtime and production losses, improve reliability, optimizes maintenance. Vibration analysis can help optimize maintenance costs and resource allocation, enhance safety. Vibration analysis can help identify potential hazards and enhance safety, supports compliance. Vibration analysis can help support compliance with industry regulations. So, what are the applications? Manufacturing. Vibration analysis can be used to monitor conditions of motors, gearboxes, conveyors, and machine tools. Automotive. Vibration analysis can be used to design, develop, and test components like engines, transmissions, and suspension systems. Aerospace. Vibration can be used to identify issues like excessive vibration, resonance, and material fatigue. In aircraft systems, wind power. Vibration analysis can be used to monitor turbine health in order to identify blade imbalances, gearbox failures, and or bearing defects. So let's move into frequency. Frequency is important because it determines the rate at which a wave repeats itself, impacting various aspects of our world, including sound, pitch, light, color, and electrical systems, where maintaining a consistent frequency ensures proper functioning of devices and overall system stability. Essentially, it is a critical factor in how many different types of waves behave and interact with each other across various scientific and technological fields. In the human body, certain frequencies cause good and bad reactions, especially in the brain. Good frequencies are 963 Hz, 528 Hz, and 777 Hz, the golden frequency. So we have human hearing range, which goes from 20 Hz to 20,000 Hz. Balance the spectrum. A good frequency response means a smooth distribution of sound energy across all frequencies within the audible range without significant imbalance. Specific healing frequencies. In alternative healing practices, certain frequencies like 528 are often considered good, as they are believed to promote positive effects on the body and mind. So the importance is sound perception. In sound, different frequencies that correspond to different pitches, allowing us to distinguish between high and low notes in music. Light spectrum. Visible light is composed of different frequencies, with each frequency appearing as a specific color in the human eye. Electrical systems. Maintaining a stable electrical frequency is crucial for the proper operation of motors and other electrical devices. Communications, radio wave, microwaves, and other forms of electronic waves. Electromagnetic radiation rely on specific frequencies for transmission and reception. Medical imaging, as we already talked about, the MRIs. All right, so now let's move on to sound levitation. Also known as acoustic levitation, is important because it allows for the manipulation and suspension of objects in mid-air using sound waves, enabling applications in various fields like manufacturing, research, and medicine, where handling delicate materials without physical contact is crucial, including the ability to study sensitive materials without contamination, precisely position tiny components during assembly, and even deliver targeted drops within the body. So key points are non-contact manipulation. Sound levitation allows to handle fragile and sensitive materials without direct contact, which is vital for research in fields like biology, where even a slight disturbances can affect the samples. Containerless processing: by suspending materials in midair, it enables processing of materials without the need for containers, which can be crucial for chemical, reactive, and or highly sensitive substances. Precision control: by carefully directing sound waves, researchers can precisely position and manipulate tiny objects with high accuracy. Microchip manufacturing: acoustic levitation can be used to levitate and assemble microchips without the risk of damage from traditional handling methods. Medical applications: potential applications in medicine include targeted drug delivery, manipulation of small tissue samples, and even breaking up kidney stones using focused ultrasound waves. Research opportunities: studying the behavior of materials in a completely free-floating state can provide new insights into their properties. There are some limitations, of course, and this is like the in the general knowledge realm of the world right now. So it's effective for small objects. Generating the sound waves necessary can consume a high level of power, and precise control, it's still challenging. But there's a story about a guy that knew the techniques that they used in the pyramids thousands of years ago, how to build them. So he by himself built a 1,100 ton castle in Florida. So you can search for it. It's the Coral Castle. And this is a Latvian guy that came 80 years ago, something like that, and built. These are some pictures of it. I mean, gigantic stones. And the entrance has like a 10-ton, perfectly balanced. You can move it with your finger, and it swivels. So you enter to the Coral Castle. So he simply, when was asked, "How did you do it?" and he said, "I know the techniques that were used in building the ancient pyramids." So, but basically, he never gave that knowledge to anyone. This is, to me, this is just to prove that one person with that knowledge can create something as amazing as the Coral Castle in his lifetime. Okay, let's move to numbers. Right. So these two are basically, the left one is the vortex math, and the right one is the multiplication map. So in the left one, Tesla noticed that when you double your number, it creates a series. So a series of 1, 2, 4, 8, 7, 5. And it repeats itself when you add the numbers to the left column here. So what happens with that is that if you take that series and add the two numbers, they will always add 3, 6, 9. So famously, Tesla said, if you know that the universe is basically a set of numbers that will always add 3, 6, 9. So this is represented in this diagram. So here you have the series 1, 2, 4, 8, 7, 5 and repeats, and then the 3, 6, 9 right there. And in the multiplication, I love this because it shows the relation between math and the geometrical shapes that we all know. So you can see here we have the perfect triangle, we have the square, we have the diamond, we have the hexagon, which by the way is the most important shape in the universe. So if you want to learn more, take a look at my book, the third book, Enrich Me, and I explain why the hexagon is so important. And this one talks about the primes as well. And I love the spiral. The spiral, you can see that from this point, the spiral starts going left, and from this point, another spiral starts going right. So if you want, I can share you this presentation. So let me know. Some key numbers in the universe for us are these. So basically, the Earth moves 1 grade every 72 years in the astrological um, diagram. So 7 and 2, it's 9. The base circumference of the Earth is 43,200 kilometers. It's 9. It divides on base 600, then 6, and latitude of the pyramid is 30 degrees. So that's 3. The full cycle of the solar system around the Pleiades, it's 25,920, which is 9. And the zodiacal age that we already talked about before, 2,160, it's 9, right? Very interesting. So other key numbers in mathematics and in the universe. So we have the golden ratio, which is approximately 1.618. It's a rational number found in many natural phenomena, from the spiral arrangement of the seeds in the sunflower to the proportion of the human body. It's often considered aesthetically pleasing and used in art and architecture. The Fibonacci sequence. Each number is the sum of the 2 preceding ones. This sequence appears in various natural patterns, like the branching of the trees, the arrangement of the leaves in the stem, and the spiral patterns of the seashell. The ratio between successive Fibonacci numbers approaches the golden ratio as the sequence progresses. We have pi, which I'm sure you all know what pi is. Is a circle's circumference to its diameter, fundamental constant of mathematics, physics, and trigonometry and geometry and calculus. And the Euler's number, approximately 2.71828, the base of the natural logarithm. It appears in various areas of mathematics, physics, including calculus, compound interest, and the growth of and decay of many natural systems. These are just a few examples of the fascinating numbers that seem to underlie many of the patterns we observe in the universe. Whew. 1 hour. I want to invite, if you're looking at this video, to join us in these talk shows. We do it once a month, every Sunday at 7 p.m. And yeah, so basically, after I give all the topics, then we have a chat and a dialogue. and we look at the questions that you may have. I also give you videos about the topics that we're gonna see. So basically, some people say, "Oh, I don't know anything," but basically, you don't need to know. We give you the videos, and the most important thing is for you to bring questions, 3 questions, and so that's how knowledge gets really created, is with your questions, and we all try to answer those. All right, so thank you so much, and have a good evening.